Ta-da! So this is interesting, isn't it? It's there's a lot of people in school, so that, I mean, that's cool. Although it seems that the majority of the people who are in school are the ones that have normally been tuning in regularly for the stream. So it's going to look like there's not that many people in the live stream, but it will remain up in perpetuity, so they can catch up on it there. How are you guys doing? Anyway, the 6 of you now who are watching. 6 viewers, 3 likes. That's 50% of people think it's all right. So, how you doing? Is it good? Just out of interest, how many of you have actually been? How many of you have been back to school so far? Is it all right? I mean, I know that some of you can't go back for whatever reason, and you've been tuning in to my lesson feeds on Discord. I hope they're, I hope they're easy enough to follow. I'm gonna, like I said before, I'm gonna make some YouTube specific stuff for so the lessons that we do in school, they're linked in with what we're doing here, but they are separate. I'm not going to set extra work, for people that are going into school and stuff like. I mean, we'll see how it fits around. But basically, what I'm saying is, the long way around is, I will produce a YouTube video which covers all the stuff about testing and whatnot that we're doing in school. So those of you who have had a lesson about testing will know what I'm talking about. Those of you who have not yet had a lesson, well, you've got a whole bunch of fun stuff to look forward to there. It's good to see you all like actually as human beings again, instead of just random text messages on the internet, so that was cool. Those of you who are maybe not up to date on all of your work, I'm not going to get mad at you for missing live streams and stuff like that. But it's in your best interests to get caught up as best you can. Now, I'm not saying that what you should do is sit down and spend 3 solid days going through all of my videos or anything like that, but any of the videos that have streamed that you haven't watched, any of the work that has been set that you haven't done, aim to get that done when you can. Don't take too much on. I mean, if you aim to spend an hour on it a day, you'll get caught up in no time, right? Just got an email, so let me just double check what's going on there. Right, okay. Good. Anyway, right, let's get back to it. So we're going to carry on with what we did from in the last stream. So this is not following on from the in-school lessons. It's following on from the last lesson that we did about designing robust programs, where we looked at things like validation. Hello, Ben. Good to see you here. And by that, I mean both Ben Knox and Ben Pittaway. I assume Ben Lindsay is floating around somewhere as well. But yeah. So we're carrying on with our stuff about designing robust programs. I just want to quickly recap. There was a word beginning with V. The word beginning with V is how one of the methods that we use in order to make sure that input to our program does not break our program. It's also a method to make sure that, yeah, there we go. Ollie's on it straight away. Validation. Just out of interest, can any of you give me a specific definition of what validation is? If I said to you, I am about to press a button which will immediately destroy the universe unless you can give me an adequate description of what validation means in a single sentence right now, what would you say? The action of checking or proving the validity or accuracy of something. That's fairly vague. Remember, we're talking specifically about validation in computer programs here. And by the way, James, this is like the year 10 stuff, not the year 9 stuff. So I know I sent a message out on Show My Homework saying that I'll be streaming about 11:15. If you've tuned in expecting that one, hold off. We'll be coming back. Okay, there's not. I mean, what you've said is correct. The action of checking or proving the validity or accuracy of something, that's true, right? But we're talking specifically about computer systems here. Password validation, right? I mean, that's an example of one use of validation. But if I said to you, "What's validation?" and you said, "Oh, it's just validation," well, that doesn't really mean anything, right? So make sure that what you're doing is what you're allowed to do or what you can do. I mean, that's not too bad a way of putting it. Checking the code meets the accurate criteria. We're getting closer to a solid suggestion here. It's basically making sure that inputs to the system are reasonable. It doesn't check to see if inputs to the system are correct. Yes, sensible and reasonable. Those are the two good words. Nice one, James. Well done. Okay, so you guys know what validation is. Now, at the end of the last lesson, we were talking about runtime errors, right? Handling runtime. Can anyone remember, or can anyone give me an example of a runtime error? Any examples of a runtime error? Overflow error. Yes, in specific circumstances. So, for those of you who are thinking, well, how could a runtime error? How does that relate? How do overflow errors relate? That's where, let's say, you're adding a bunch of stuff up and you haven't allocated enough space. Your code works fine, right? But when you run the program, there's an issue with the calculations which cause things to go wrong. I mean, remember those examples that I gave you of overflow errors messing up games, like when you're nice to Gandhi and he likes you so much that he declares nuclear war on the entire planet. That's an example of an overflow error. Nothing necessarily wrong with your code, but when the program is run, there's that overflow happens there. Input int age Bob. Input age. Yeah, that's more like it. Yeah. So if you're asking for a user to enter a number, and then you try and convert that to an integer, and they've typed in something which is clearly not numeric, it's going to throw up an issue. Other examples that you could have had include a divide by zero error. Trying to calculate the square root of a negative number, but yeah, you guys get what's going on there. So nice one. All right. So I think this is where we left off last time, handling runtime errors. So if you haven't got this stuff down, now's the time. To handle the runtime errors, we prevent known bad input. So anytime you have a place where the user can enter some sort of input, trying to anticipate the sorts of input that they would enter and preventing them from entering the bad stuff. Like if you want them to enter a number, then why not lock off all of the keys except for the number keys? That way they can only enter numbers, right? Or maybe not necessarily lock the keys off, but when they press them, make sure that it removes any non-numeric characters from your text entry form. There's one example. Okay, handle unacceptable input gracefully. That is to say, if they do type in something that's going to make the program crash, instead of actually crashing, catch those errors and say, "Oi, that shouldn't happen. I'm going to do this instead." There's this thing called exception handling, which I very, very briefly went over at the end of the last stream, and I showed you some Python examples. So, plan for this this lesson is we'll go through some examples of specific types of validation, and then we'll have a look at something called input sanitization, which you might have heard of, you might not have heard of. Input sanitization is a way to try and prevent things like code injection, which can be bad. And we'll have a look at specific techniques in Python to sort of catch those errors and fix the problems as you go along. Okay, if that sounds cool, then put a fun emoji in the chat. If it doesn't sound cool, then put a I don't know, a different emoji, a not fun emoji. I don't know what kind of emojis you want to use, but well, I mean, regardless of whether that sounds cool or not, that's what I'm doing. So you don't get a choice in the matter. Do you hear that sound? That was the sound of another email coming in. So just to reiterate this, validation, checking inputs to make sure they are reasonable, not necessarily correct, right? When you're writing an explanation of validation, never use the C word. C word is banned, okay? Reasonable, sensible, those are valid, haha, see what I did there? Valid words to describe validation. You can't use the word valid. If you say validation is checking inputs to make sure they are valid, well, that's a circular thing. It doesn't really tell us much, right? So checking inputs to make sure they are reasonable. It does not check to make sure that they're correct. If I say to you, "What's your name?" right? And your actual name is Jim, for instance, and you say, "Well, my name's Cynthia." I mean, Cynthia is an acceptable name. That's valid data. It's not correct. Do you see what I mean? There's a distinction to be made between reasonable and correct there. So I've missed off an ending quote here. Reasonable in this case means within the bounds of what the program expects. And obvious example, it's obvious. If entering an age value, valid data is numeric, invalid data is non-numeric. You might also want to have some other kinds of validation, which is the question on the next slide. So checking to make sure that the data type that you have entered is the data type that we're expecting is just one form of validation. Did my finger come up there? One form? Maybe, I don't know. I got looking at the wrong screen. Yes, I like that. Does anyone? There's a guy that plays piano, Brazilian guy called Vin Hetero. And before he plays the piano, he holds up his finger to the screen like that. I don't know if you guys have watched him, but anyway. So, besides checking to make sure the data type is correct, can anyone think of any other types of validation that we might carry out to make sure that our data is going to be handled properly by our program? Just like have some wild guesses, okay? I don't care about wrong answers. I just want you to have a think. What other things might we check for user inputs to make sure that they are valid? I'll give you a few minutes. In fact, while you are thinking that, how about I play Circus of Freaks to get you thinking? Here's the Circus of Freaks music. So this is 56 seconds long. I'll give you 56 seconds until I have a look at the answers you got there. And I appreciate there's only 4 of you, but you know, let's make it seem like there's loads more. Length is correct. Length is one of the things that we can check. Anything else? This music's a banger. Listen to it, man. So we've got length. Anything else? Any other things that you might check? Oh, that music ended abruptly. Right, okay, so Any thoughts that might be in your head? But yeah, okay, format. Yes, format is a thing. Can you explain what you mean by format, or is that just sort of like, oh, that sounds like a good word to use? I mean, obviously, I'm going to be going through all of this stuff. I'm just interested to know what you know. Isn't it really hot today? Spell. Um, Is that like a wizard spell? Or do you mean like check to see whether it's spelled correctly? If something is the correct format, maybe a date. Yes! That is a really, really good example. Like if someone is asking for a date, and you're expecting, I don't know, a day, month, year, or if you're American, month, day, year, which never made any sense. You want to check to make sure that everything that's in there is yeah, it was hotter yesterday. I don't know. I don't think I'm really built for the heat. I thrive in the cold. I run pretty hot usually. Check for known code injection methods. Yeah, we're going to get onto that. Right. Okay, what I will do now is, rather than keep saying, "Hey, how much about this stuff that I'm supposed to be teaching you do you already know?" Because that's a lazy cop-out way of teaching. Here we go. So these are the different things that you may need to know about. Okay. Spell check looks at words in a dictionary. Okay, yes. So that is a type of formatting check. If you say enter a word that actually exists, you're going to want to make sure that it actually is a word that exists. So data type check is the obvious one that we've gone over. Does the data that's been entered match the expected data type? If you're looking for a number and the user enters the word apples, apples is not a number, it's the wrong data type, that data is invalid. And before you start saying, oh yeah, well Python can convert to different data types, yes it can, right? But remember, something has to actually look like the other data type before you can convert it, right? So when you enter something into the Python input command, it's always a string. Even if you type in like digits, they will be digits in a string, and you have to convert to a different data type. However, trying to convert something which is not numeric into an integer in Python will crash your program. And so you need to check to make sure that it fits the what that data type should look like before the conversion. And that all falls into the same category of a data type check. Make sense? I can't remember if I shared this presentation up on the Classroom or not. I'll endeavour to do that. So the next type of check is a range check. Okay, a range check. Does the value of the data lie between expected bounds? That is a fancy way of saying, is it in between the maximum and minimum values that you're expecting? Okay, so if I'm asking the user to enter an age, I know I use the age example for everything, but it works in lots of different situations. We would expect the age to lie somewhere between 1 and 120, probably. And there's not many people that live beyond 120 years, and there's certainly no one that lives for minus 10 years or anything like that. So if we're asking for an age, we want to check to make sure that it's within reasonable bounds. Yeah. If you are asking someone to enter their the month they were born in, and we want it in a numeric format, it's going to be a number between 1 and 12, for instance. Those are our ranges. Yeah. If you are asking someone what the average Where am I going with this? No, I was trying to think of a funny example, but I'm obviously a less funny man than I thought I was. Welcome to Josh, who has arrived. We now have 7 concurrent viewers. So the thing with range check is the program might not instantly crash. Like, I mean, if you put the wrong data type in, the program there's a high chance of the program instantly crashing if you haven't tried to catch that error. But with a range check, the program might not instantly crash, but it could lead to logic errors. And remember, logic errors, they're horrible because they're difficult to track down. Okay? Do we get what a range check is, yeah? Oh, these late people coming in. Are you only just woken up or something? We get range check, yeah? Sweet. Right. Presence check. This is Darth Vader's favourite. Does the data exist? Has it been entered? You will have probably encountered presence checks all the time. I encounter a presence check throwing something in my face pretty much every time I set any work on Show My Homework, because it always, rather than selecting the default no marking scheme required, it forces you to select one of those options. And if you haven't selected anything, then that data is not present, right? And so you get a message saying, "Oi, we need to enter this." Okay. Anytime you filled out a web form and there's one of those boxes that says this is required, there's a little asterisk next to it, and you hit confirm without entering that data, it will probably spit it back in your face, maybe highlight the box in red and say, "What are you doing? Give me the data." Okay. So presence check basically is a check to make sure that the data actually exists. Because it will be data which is crucial to the program function, and if that data isn't there, the program doesn't work. So we need to make sure it exists. Now that might be, there's 2 ways that you can do it. You can either keep on pestering the user to say, enter that data. No, enter that data. I told you to enter that data. Enter that data. Okay, cool. Now I've got that data. Or you can just set it to a default value. So if the user doesn't enter the data, then the system will say, "Oh, they didn't enter data. I will assume that this is the default value," right? So enter a rating for this book. How good did you think the book was? It's between 1 and 5, so you could have a range check in there potentially. If the user doesn't enter anything, maybe it defaults to 3 or something. I don't know. I didn't make Goodreads.com. Don't at me. Okay, we're all on board with presence check. Yeah, makes sense. Incidentally, once we've gone through all of the types of validation check, if anyone wants to come up with some handy mnemonic for remembering the different types, that'll be cool. I never really thought of that because I just remember them, but I know that some people prefer to remember mnemonics. Oh man, what was the one that Ollie had? It was hilarious. I can't remember. I'm gonna have to ask him. Right, format check, and this is something that Jennifer mentioned. Does the data match the expected format? Not to be confused with Datatype. Remember, we're not talking about the actual type of data, we're talking about the way that the data is arranged here. There are many examples that you can use. The example that Jenny suggested was date, which is a brilliant example because you usually have year, month, day, and sometimes it will be a case of 2 digits, a slash, 2 digits, a slash, 4 digits, or something along those lines. Postcode is another example. You usually have 1 or 2 letters followed by 1 or 2 numbers, and then a space, and then a number followed by 2 letters. I think that's the way that it works, okay? An example here, an email address. An email address is a number of characters, any characters, followed by an @ symbol, and then followed by a bunch of more characters, and then a dot, and then some more characters. Okay, now that's not necessarily going to check to make sure that email address exists, but it can at least check to make sure it's in the right format. Does that make sense? Yeah, what a format check is and the difference between a format check and a data type check. Yeah, good, cool. We've now got 9 viewers. Wow, 9. What a peak! What a peak! What is the next thing? A length check, not to be confused with a range check. Right? Remember, a range check checks to make sure that your value is between a specified maximum and minimum. A length check checks the length of the data. Ordinarily, I mean, for the most part, this length check is applied to strings, but it doesn't have to just be applied to strings. So if you've got usually a password, if you've got a password, it will be a minimum of 8 characters if it's any kind of secure password. And so if you type in a password which is only 7 characters, the length check says, no, it's got to be at least 8. Okay. Now it might be that you have a maximum number of characters that it can be. Okay, if you're entering a name, for instance, the example I used in school the other day was maximum length of name. Was it 15 characters? I can't remember, but we came up with the name isopropyl, that wonderfully scientific girl's name. And that we decided that was the maximum length for the name. But you see what I mean? We're talking about the length. The number of characters in the string is the length. 10 characters, yeah. However, it doesn't just have to apply to strings, right? A length check could also apply to, say, a file size for an upload. The length, if you like, is the number of bytes. It's the number of pixels in an image. You know, that's a type of length as well. Does that make sense? For the most part, you guys are going to apply it to a string value, but it can also apply in similar contexts. Make sense? Do 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 do. What's next? Oh, those are all the types of validation check. Let's just make sure we got all of these. So we had data type, range, presence, format, and length. If you wanted to come up with a wonderful mnemonic or acrostic, or whatever those things are called, to help you remember them, then that's brilliant. Best one gets a house point and makes it onto my lesson presentations for next year. We shall see about that. Right, so validation is one way of trying to limit the user input to make sure that we catch any potential errors and prevent those runtime errors from occurring thanks to user stupidity, right? But it's not the only way. It's not the only way. Okay, now this is a fairly dry subject, so I put a picture of a pangolin on here. But the pangolin himself has nothing to do with programming, really. He's a nice animal. Kind of looks like a Pokemon. I mean, when he's walking along, he walks on these 2 hind legs, and those front legs he just holds in front of him. It's very cute. Don't know if you've ever seen a video of a pangolin. They also have long tongues. They eat ants, and their scales are designed to stop the ants from getting them. Pangolins, but pangolins are an animal. I mean, I'm not sure if they're related to armadillos. But they're fairly similar. They can roll up into balls as well. I mean, armadillos are one of my favourite animals ever. So the pangolin is right there with it. Okay. So no disrespect to armadillos here, But yeah, pangolin, armadillo. Armadillos are, I think they're more closely related to sloths. Or I can't remember if pangolins are related to anteaters. Anyway, none of those animals will help your programs become more robust. Yeah. However, input sanitization might. What a segue! Do you see that? Yeah. Subscribe to my Patreon. So input sanitization is something which guards against code injection. Can someone just remind me what code injection is? An aardvark's quite nice. Aardvark is nice. Code injection. Anyone know? I mean, the example here might give you a clue. Using code like SQL in an input box for malicious purposes. Yeah, I mean, code injection is where you have the opportunity to enter something into a program and you can insert code in there which could potentially be executed by the program, thus allowing you access to a system. Okay, it might not necessarily allow you access to the system. It might just corrupt the data in the program. It might allow you to execute code which could, like, trash a hard disk or something like that. But the whole point of code injection is you are injecting your own code. You're tricking the program into running your code instead of treating what you've typed in as just like any other kind of input data. An example that I've put down here, an online message board, if such a thing still exists. When you enter some data, most of them will guard against these symbols, because when you type in HTML, each HTML tag is surrounded by these symbols, and if you are editing something on or if you are entering data into an online message board, if you use you can use an HTML tag to insert your own code in there. You could use a script tag, maybe, which would inject your own JavaScript code into the message board. You could use an HTML tag to even perhaps redirect the web page to a different website if you were a fan of farming or fishing attacks, for instance. Okay, and so what most message boards will do, if you put this in your HTML code, ampersand LT semicolon, when it's rendered on screen, it will be replaced with this character. So this here is the substitution for this character, and this here is the substitution for this character. And what that means is you'll be able to write something that looks like an HTML tag, but it will just render on the screen as an HTML tag. It won't actually be interpreted by your browser as being HTML. Online message, well, I mean, they're usually called forums, right? I used online message board because, I don't know, just stop people saying, what's a forum? But you know what I'm getting at, right? Do you see what I mean by input sanitization? Other methods of input sanitization might be if someone puts a quote mark in there, or any kind of special character, putting a backslash in front of it. Because backslashes are usually escape characters, and that tells the system, oi, ignore the next character. Okay? I mean, you don't really need to know, at GCSE level, you don't need to know a great deal of the ins and outs of code injection and input sanitization. There is a really good website where you can practice your own kind of code injection so that you can sort of learn the sorts of attacks that you might have to prevent against. But if anyone's interested in that, I'll put a link on the Discord channel. Okay, anyone got any questions about input sanitization here? That's basically taking the code that someone has made. The word sanitization, here's some tier 2 vocabulary for you. Go and find me a definition of the word sanitization. I mean, you might already know what the word sanitization means. I mean, you certainly know what hand sanitizer is, right? We got a definition? Sanitisation. No one knows. No one knows. No one knows what sanitisation means. I'll just do a quick search, shall I? Removing unwanted characters from an input. Yeah, I mean, in the strictest sense, sanitizing something means making it clean. Yeah? If I sanitize my hands, it removes nasty bacteria and viruses that might cause illness. If I sanitize my kitchen, it means I'm going to scrub down the sides so that germs and stuff can't breed. Yeah? If I sanitize my inputs to a computer system, it cleans them up so there's no potentially harmful code there. Okay? So that's what we're talking about with sanitization. That all makes sense, right? Remember, if you can't remember what input sanitization means in a computer science sense, just think of hand sanitizer. Hand sanitizer cleans your hand. Input sanitization cleans your inputs. Now there's this other thing which I briefly mentioned at the end of the last stream, exception handling. Exception handling, which is not necessarily something that you need to know at GCSE, but I think it's so useful that you guys should know, and so I'm giving you a head start over everyone else by teaching you about this stuff. Exception handling, this is one of those ways that you can sort of anticipate the areas where your computer, where your program might break due to user input, and prevent it from doing so. And there's a number of ways. Well, there's a number of different types of error that you can search for, or you can just generally say, "Ooh, if any error occurs, don't crash the program," which is not always a good way of doing things, because that prevents you from actually working out if there are bugs. Okay, so exception handling is where you anticipate some of the data which can cause the problems in the program which make it crash. So remember, the users are generally idiots. So thinking about, right, what kind of idiotic things are they going to do with my program? And you put in workarounds. So when you say, give me a number, and they type in, I'm not giving you a number, lol. Instead of the program crashing when it tries to convert that string to a number, you actually say, no. I said, give me a number. Either give me a number or destroy the universe. And then it loops back round and it asks for the number again. Maybe a less bellicose error message. There you go. I used the word bellicose. What are you going to do? Yeah. You didn't realise this was an English lesson as well. What does bellicose mean? If only there was an online dictionary. So, for example, a divide by zero error in a calculator. If someone tries to divide by zero, instead of the program just blindly saying, "Oh, they want to divide by zero, I better try and do that. Oh, now I'm dead." The program instead will say, wait a minute, they're trying to divide by zero and I can't do that. If I try and do that, that's the end of me. So instead of doing that, I'm going to give them a little message, and I'm going to ask them to do something different. Does that make sense? What exception handling is, I can give you a hands-on example right here. And this is similar to what I showed you at the end of the last lesson. But I also want to show you some extra programming stuff and introduce the concept of flags so that you can continually ask the user for input until they enter valid data, right? So redirecting the flow of a program, that should say if an error is detected, not is an error is detected, because that doesn't make any sense, rather than flat out crashing. So this is how I've done it in Python. Age equals input, how old are you? You will notice I'm not directly converting that to an integer, because if I directly convert that to an integer, there's no way I can trap this error. Okay? So then we try to do this. We try to convert whatever they've typed in to an integer. Now, when you try and convert something to an integer, if it doesn't look like a number, you will get a value error. The traceback will say value error. In fact, I can show you this right here, right now. Let's turn on my PyCharm. Where's PyCharm? Where is PyCharm? There we go. Let's zoom into my Python console here. If I say let's just do int hello, right? This should give me an error message. There we go, right? We get value error, invalid literal for int with base 10, right? Now, you probably haven't realized that every time you get a traceback, it tells you the type of error that you're getting. Right? That is actually really useful to know, because there's multiple different types of errors that you can handle differently. Yeah, there might be. Let's do. I don't know. There we go. I get an index error because I've tried to access a different part of the list compared to what actually exists. Yeah, I don't actually know if I can convert an empty list to a Boolean. Yeah, I can. Okay, well that's that error. But the point that I'm making here is that you get different types of error depending on the things that you have done, and you can specifically check for those different types of error. While not type age equals int and 0 is less than age is less than 121, age equals input age. That won't work, because I'll tell you why. Oh, it does work. They changed the syntax. You used to have to actually put the thing in there. Yeah, I mean, in theory you can do it that way, but that's kind of a crap way of doing it, because it makes your code less readable, and also trapping the errors gives you the opportunity to give the user some feedback on their error, right? So let's just go back to my presentation here, and then I'll give you some more code examples. Just a quick summary before we go back to the programming. Robust programming is all about anticipating misuse of the program, right? So a lot of it comes down to the way that you code your program, but it also comes down to you thinking, right, how is the end user actually going to use my program, and how can I sort of guard against bad things happening, right? I've put either through malicious intent or incompetence, right? Never attribute to malice that which would also be attributed to incompetence. That's Harlan's razor, I believe it is, which is different to Occam's razor. Allowing errors to be trapped and handled gracefully so that the whole thing doesn't fall over, right? So let's have a look at one of the ways that we can actually get some decent validation into our programs, right? I'm going to introduce you to the concept of flags. Okay, a flag is a Boolean value which says whether something is true or not. Okay, and we can store them as variables, and we can always check, is that flag on, is that flag off, right? So we can have a flag that says whether the input that we've typed in is valid or not. We're going to assume that our input is false to start off with. There is a flag, right? Set up a Boolean flag, right? You use flags all the time in pretty much any program that you are making, right? Any program of any substantial length, anyway. So what we can do now is we can continually ask the user to enter a number between 1 and 10. Let's think about how we're going to do this. So we can say something like, while not valid. You notice how I've named my flag something so that when I read the code, it makes sense to me. We're constantly going to do this while our input is not valid. Yeah. Let's say, whatever. Let's do age. Age equals input. How old are you? Okay. Now I'm going to show you two different ways that we can sort of like trap some errors here. We want to make sure that the range is between 1 and 120. We also want to make sure that it's actually a numeric value. So we can do multiple different checks here. We can say if age dot well, let's see if it's not numeric first. If not age dot is numeric. So if what they've typed in isn't even a number, yeah, we are going to then print out an error message saying enter a numeric value. Okay, and if it is numeric, we're then going to convert it to an integer. We're going to say age equals int age, and then we're going to do another check, right? We're going to do another check that says if not, no, actually we won't do not. We'll just say if 1 is less than age is less than 120, or maybe that should be 0. So we're checking to make sure that age is between 0 and 120. If it is, everything's great. We can set valid to true. Otherwise, we're going to print out another error. Okay, so now this is not the most elegantly written program in the world. Okay, but we've got some rudimentary validation in here. So if I run this program here, he says, trying to run the program. It didn't work. Control Shift F10. There we go. I'll scroll down so you can still see the code. How old are you? If I type in goons, error, enter a numeric value. Okay, so we've checked to make sure that it's actually numeric, and if it's not, we've said enter a numeric value. Now notice at this point, because what we've typed in is not valid, and it's also not numeric. We skip over all of this, we go back here, it's still not valid, so we're going to ask them to enter another number. This will continue forever until we actually enter a numeric value. Now if I put a ridiculously high number in there, we get a different error. Okay, so at this point it is numeric, so we can skip down to the next part of the validation, right? And then it's going to check the range. Okay, so this here is our data type check, and this here is our range check. Okay, now as I said, this is not the most elegantly written program here. What I would normally do is create a function called validate. Okay, because then it can either return the valid data, or it can return an error, right? How old are you? Let's type in, I don't know, what, 29, let's say 29, we're 29. You are 29 years old, okay? So we don't actually exit that loop until we've entered valid data, and then we run that that code down there. Does that make sense what we're doing here with this flag here? So we're setting up a flag, and we're saying constantly be doing this until we actually get some valid data. Does that make sense? Yeah, makes sense. So a way that I can sort of make this a little bit better, as I said, if I have that function called validate, what this is going to do, it's either going to return true if something is valid data, or it's going to return false if it's not, right? So we can say, let's do our data type check. Return false, and then we can do our range check. Now I'm not putting an else in here, because remember, with functions, as soon as you return, you've exited the function. So if we're still here by this point, we know the data is numeric, so I don't have to worry about the next bit where I say data equals int data. Maybe I should actually print out an error message here. I could say print enter a numeric value, and then down here I can say data equals int data if what did I say, 0 is less than data is less than 120. Return true, because it's valid data at that point. Else we're going to print out an error message. And then return false. Okay, so there's our validation check here. Now we still have this loop down here. So we're saying while not valid, age equals input, how old are you? And then we're going to say quite simply valid equals validate age. Okay, so I mean that's separated our actual validation function from the main code here, and it allows us to add specific validation checks in there. Like I said, I mean this is a quick example that just popped into my head. It's not like I sat down and planned this out, so there's still areas for improvement, but that's a little bit easier to read and a little bit easier to get to grips with. And also it means that if you then later on need to validate some other stuff again, you can call the same function without having to duplicate your code. And just to prove that it still works, how old are you? I type in this, it will enter a numeric value, blah blah blah. Right, let's enter a ridiculously high numeric value, let's enter a ridiculously low numeric value, let's enter a sensible value. I don't know, how old are we? 98. You are 98 years old. Does that make sense, what's going on there? You get the idea of the use of flags here. So that flag, this is a loop which is perpetually going around and around and around until we set that flag, and that flag is set by the return value of this validation function. And validation function very simply just either returns true or false, but we've got the opportunity to print out some error messages for the user there as well. With that, do you think you'd feel confident enough to implement your own validation techniques into programs such as your text-based adventure games, for example? Just say yay or nay. Is there anything about this code here which doesn't make sense? Anything that you want me to go over a little bit more, or anything you want me to clarify here? And the other thing as well, I mean, we could even put another, we could put a presence check in here. Let's do that. We could say if len data equals 0, print actually type something in, you muppet, and then we can return false there. Okay, if I run that code now, we should get an error message if I just hit enter. Actually type something in, you muppet. There we go. Did the stream just die? I mean, it seems to be working, right? Mine says name error validate is not defined. Have you actually defined the function here? And have you defined your function before you call it as well? It's vitally important. Just double check the spelling as well. Make sure that your spelling of validate is correct there, and it is correct there as well. Does that make sense, how we can easily add these extra validation checks to our validate function as well? Yeah, I mean, I've lost track of the number of times where I've run into errors because I've misspelt the name of a function somewhere or misspelt the function call. Tab completion is your friend, I guess. Cool. So, I mean, there's 3 types of validation check right there in our validate. Now, one thing that I haven't done here, I haven't put any exception handling in here. You could, in theory, put some exception handling in there rather than having these basic validation checks. But I leave that as an exercise to the viewer. There we go. Me being a maths textbook right there. Validate. Validate. Validate sounds like a Renaissance painter or something. It's like, oh man, I wish I could afford to have a validate on my wall. Validat, validat, maybe. Yeah. Cool. I mean, that's about it from me. Does anyone have any further questions or any bits that they're not sure of right now? Nope. Cool. Right. In which case, I don't have any specific work for you to do. But what you might want to do is maybe go back to some of your old programs that you did and see if you can just add some validation to the inputs there. Okay. And that's that. If you run into any problems, give us a shout on the what's it called? Discord. Sorry, I got distracted by the nonsense in the chat. That's that. All right. Thank you very much for your time, everybody. I shall see most of you in a few days.